This is Honors Geometry Lesson 2.2, Conditional Statements. A conditional statement is a logical statement, and it has two parts. It has a hypothesis, which is the if part of it, and it has a conclusion, which is the then part of it. So if we have an example, if today is Tuesday, then tomorrow is Wednesday is a conditional statement. The if today is Tuesday is our hypothesis. Our conclusion is then tomorrow is Wednesday. First example says rewrite the conditional statement in if-then form. It says when x equals 6, x squared equals 36. So we'd say if x equals 6, then x squared equals 36. If x equals 6 is our hypothesis, our conclusion is x squared equals 36. The negation of a statement is the opposite of the original statement. So if my original statement is the pan is hot, my negation is the pan is not hot. But if my original statement is the test is not hard, then the conclusion or the negation is the test is hard, because we would not say the test is not hard. So we'd say the negation is the test is hard. A conditional statement can be true or false. To show that it's false, you can simply find one condition where the hypothesis is true, but the conclusion is false. So maybe an example would be, if today is Monday, then we have school. A counter example would be, say, Labor Day. It's Monday, but we don't have school. The hypothesis is true. It is Monday. The conclusion is false. We do not have school. To write the converse of a conditional statement just means switching the hypothesis and the conclusion around. If the measure of angle equals 90 degrees, then it's a right angle. The converse of that statement would be if angle A is a right angle, then the measure of angle A is 90 degrees. To write the inverse of a statement, you would want to negate both parts. So instead of saying if the measure of angle A equals 90 degrees, we would say if the measure of angle A is not equal to 90 degrees, then angle A is not a right angle. And the last one is called the contrapositive. We do both of those things. We're first going to switch it around. We're going to take the converse, and then we're going to do the inverse. We're going to negate both parts. So my original statement was if the measure of angle A equals 90 degrees, then angle A is a right angle. Our contrapositive, if the measure of angle A is not a right angle, then the measure of angle A does not equal 90 degrees. And a conditional statement and its contrapositive are both true or false. So if a statement is true, then its contrapositive is going to be true also. And also, converse and inverse go together. So if the converse of a statement is true, the inverse is also going to be true. We call these two equivalent statements. In order to write a good definition, you should be able to check. The original statement should be true, and its converse should also be true. When you switch it around and it's no longer true, then that's not a good definition. So here's an example. A polygon is a pentagon. Oops, I'm sorry. Let's go up to the one. It says, if two lines intersect to form right angles, they are perpendicular. When we switch that around, if two lines are perpendicular, they intersect to form right angles is still a true statement, then we'd say, yes, that's a good definition. When a conditional statement and its converse are both true, you can write it as a biconditional statement. And a biconditional statement is an if and only if statement. So when you check, if the original statement was true, you flip it around, it's still true, you're allowed to write it as if and only if. Here's the example. A polygon is a pentagon if and only if it has 5 sides. If we switch that all around, it's still going to work. If a polygon has 5 sides, it's a pentagon. If it's a pentagon, it has 5 sides. So we're allowed to put that if and only if in the middle. They want us to write an if-then statement, then do the converse, inverse, and contrapositive. So I'm going to use the ants because it looks a little bit shorter for us. So we're going to say if it's an ant, then it's an insect. Put it in if-then form. The converse is switching it around. If it's an insect, then it's an ant. The inverse is negating the original statement. If it's not an ant, then it's not an insect. And finally, the grand finale, the contrapositive, we're going to do both. We're going to switch it and then negate it. So we're going to say if it's not an insect, then it's not an ant. All right, let's move on. Here we go. Decide whether the statement is true or false. If it's false, come up with that counter example. If a polygon has 5 sides, then it is a regular polygon. So I would say that is a false statement, because just because has 5 sides doesn't mean it has to be regular. So my counter example would maybe just be an equilateral triangle or pentagon, or an equiangular pentagon, not necessarily a regular pentagon. Next section, it says rewrite the definition as a biconditional statement. So they want us to put an if and only if in the middle. So the original statement says an angle with a measure between 90 and 180 degrees is called obtuse. You would say maybe something like an angle is obtuse if and only if, that's the abbreviation, IFF, its measure is between 90 and 180 degrees. Sometimes you switch it around if it makes it sound a little bit better. Determine whether a statement is valid, a valid definition. So again, we want to check the original statement, flip it around. If it's still true, then we say, yeah, that's a good definition. If 2 rays are opposite rays, then they have a common endpoint. We know that's true. If they're opposite rays, they have a common endpoint. Let's switch it around, try the converse. If 2 rays have a common endpoint, then they're opposite rays. Now that's not necessarily true. Just because 2 rays have a common endpoint doesn't mean they're opposite rays. So I would say no, that is not a valid definition. Last section, write the converse of the true statement and tell whether the converse is true. So the true statement says if x is greater than 4, then x is greater than 0. Yes, we know that's true. Let's switch it around and say if x is greater than 0, then x is greater than 4. And we would say, hey, that's not necessarily the case. Just because a number is greater than 0 doesn't mean it's greater than 4. Our counter example would be, say, 2. All right, try the practice problems. Let me know if you have any questions. Thank you.